Hi everybody, so I wanted to just finish up the rest of this lesson here. So here you can see I have this table all filled in, the years since 1950, so that goes up to 50. And then the values for the number of gallons of milk consumed on average each year and the number of gallons of soft drinks consumed on average each year. So again, just to remind you, I used these two equations that I'm putting the star by, and then T was whatever was in each of these columns. So for example, to get 30 here, to get the amount for 1980, I took 30, plugged it in for T, multiplied, and then added using order of operations. Same thing here for T, so I found the milk and the soft drink. And then I asked you to plot the data. So I'm going to show you, make sure you know how to do that, please, and then I will show you what it looks like here. So here it is plotted. Here are my two equations. So if we look at this for a minute, it kind of makes sense, right? Now, again, this part over here is, what we get when we plug in different values of x, but obviously this is not something that's physically possible within this context. We can't have negative time. I mean, we could say in essence that it went before 1950, but if we don't have data on that, it's not that this is the amount of milk here, the red one. It's not that the amount of milk was huge forever or that soda was negative, right? So you have to be careful. So we're really just looking at this first quadrant here. So here's the blue line is the soft drink line, starting here at our 10.8 gallons. Here's our milk starting at about 36 gallons. The milk continues to go down. The soft drinks go up. Now we only had up to 50, so we had up to this year right here where the milk was down in the low 20s and the soft drinks were up almost to 50. Okay, and we'll take a look back at this in just a minute. Okay, so that's our data. If you were writing it out and by hand, make sure you're labeling what each of these axes are, okay? And we want to have a title up here too you can put on there. Okay, can you use the table and graphs to approximate when the consumption of milk per person equaled or will equal the consumption of soft drinks per person? So this is one of those wordy questions. Just think about what it's asking. We want to approximate when the milk consumption equals the soft drink consumption. So if we look at the table, we can see as the years go along, the amount of milk is going down, right? And the soft drinks are going up. We know that. We can see that it must meet at some point because this goes from 10 to 49. This goes from 36 to 22. They're going to cross somewhere in the middle. Well, we can see in 1970, the milk was still higher. By 1980, soft drinks were higher. So somewhere in between there is where it's going to cross. And if we look back at the graph, where they meet is where they're equal, right? And they're crossing because this is going down, this is going up. So if I look at this point, the values of that point, the coordinates are 24.474 for x, 29.645 for y. So remember, x is the number of years, y is the number of gallons. So this means after about 24 and a half years, the consumption for each that year was just under 30 gallons. So about 24 and a half years. So think about what that means, 24 and a half years after 1950. So in about 1974 is when they would meet there. Okay, so in essence, if we're thinking about each year, it would be about 1974. Okay, let's go back to this. Then it asks us, referring to the graph, what's the significance of the point in each of the models when time t is 0? What's the significance of this in the context of the situation? So we're going to look here back at the graph for a minute. We're looking at where t, this x value, equals 0. So we're looking at this point and this point right here. Okay. What's the significance? Well, if t is 0, that means no years after 1950. So this is the amount in 1950. We can remember those look familiar, right? Those, we recognize those. And in math terms, that's called a vertical intercept. we want to use the equation models to find when the consumption of milk and soda was or will be equal. So we looked at the table, we looked at the graph, now we want to use the equation. So think about this for a minute. Here are our two equations. The milk was negative 0.276 t plus 36.4, and the soda was 0.77 t plus 10.8, right? So what I want these two to be equal. So I want the amount of milk consumed to equal the amount of soda consumed. Now I kind of already know the answer, right, from the graph, but we want to figure out how to do it with equations. Well, in this case, if I want the amount of this consumed to equal the amount of this, I'm really going to set these two equations equal to each other. So 0.276 t plus 36.4 equals 0.77 t plus 10.8. Now we want to solve for t. Okay, so we want to move things around so all of the t's are on one side and all of the numbers are on the other. We can move things whichever way. I'm going to move this term right here. So if I want to move it, I subtract it. This might look a little more complicated than some of the other equations we've done just because the numbers have a few decimal points, but it's the same process. So the reason I chose to subtract that is because then on the right side it goes away and it equals 0, right? It's 0.77 minus 0.77. So if I have negative 0.276 minus 0.77, that will equal negative 1.046 plus 36.4 equals 10.8. Oops, t here. Okay, I have all the t's together. I want to move everything else away. So I'm going to subtract 36.4 from both sides and move down here into this blank space. So negative 1.046 t equals, and then we'll take 10.8 and subtract 36.4, and we'll get negative 25.6. Now remember what we do to get the t by itself? We always divide by whatever number is right in front of that. That's because anything divided by itself is 1. Then I have negative 25.6 divided by negative 1.046, and I get 24.474 riyal, which we know, again, is about 24 years after 1950, which means it's in 1974. Okay, so when would it be the same? In 1974. All right, how do I figure out what the number of gallons for each is at that time? Well, what I want to do is, this is when they'd be equal, so this is the t, right? For when they'd be equal, here's my t value. So I want to know how many gallons at that time. I could take that t and plug it in theoretically into either one, right? Because they're going to be the same there. So if I just do a little over here, let's just say I'm going to do the soda. So 0.77 times t plus 10.8. So if I take 24.474 times 0.77 and then add 10.8, I get 29.6 gallons. Okay, so about. Now, if I did that in the other one, I should get roughly the same. It might not be exactly the same because of our rounding this number, right? 0.474 is just rounded, but it'd be roughly about. So about 29 gallons. Okay, so that's the end of this lesson. And let me know if you have any questions. Thanks, guys.